putting it all together now. So finding the roots no matter what. So please feel free to read. But the basic idea is put the equation in standard form. Make sure the highest degree is first. Set it equal to 0. Determine how many roots there are. So what is the degree? Factor first. For the love of God, try to factor first. Teach out as you go and use the quadratic formula or completing the square as needed. So I'm going to do either or just as a review. So the basic idea is this guy's got to be in standard form for me to be able to factor this. So standard form, the highest degree is positive. So 3 is the highest degree. So we know right now there should be 3 roots or 3 zeros or 3 solutions to this when we're done. So everything, this is positive. The leading coefficient is positive. So I'm going to bring everything to this side and put it in standard form too. So I move that negative 6x squared becomes a positive 6x squared on the other side, and then the 3x. So x cubed should be first, x squared part is second. Combine these two. I don't have you guys correcting me, so checking my math. All right, so it's in standard form as we go. So what we have to do first is see if we can factor. And the first thing we always look for, the GCF. All right, x is a GCF. I divide that out. I'm left with x squared plus 6x minus 15 equals 0. I T-chart at this exact moment, and this side is done now. X is 0. So factoring completely and solving, two different things. When I'm just solving, once I have this answer, this side, this done. Get rid of it. So now I have to solve this one. So I'm going to go with it can't be factored, because if it could, I know I made these up, but I forget. If they could, it wouldn't be on this one, it would be on the factoring one. So we either have to use completing the square or the quadratic formula. Now I know probably quadratic formula is your method of choice, but I'm just going to do a quick review of completing the square because it doesn't matter. So the 15 moves over. We're going to add something to this side and this side. Okay, to make it a perfect square, so x plus 3. I like to do completing the square when that middle term is even, because it's just easier to me. So divide that by 2, square it, and we have our perfect square equation. Take the square root. X plus 3 equals the square root of 24. If we break that down, it's 4 and 6, or 2 radical 6. Remember, we put the square root on, so we got to remember that plus or minus, and then simply subtract the 3. So x equals negative 3 plus or minus 2 radical 6. So factor first, and then find the rest of your answers. Do I have 3? I did say in the beginning I should have 3. Here's 1. It's sitting there. You don't really have to list it out as long as it's there, at least at some point. And here's 2 of them. Negative 3 plus 2 radical 6 and negative 3 minus 2 radical 6. You can write them out if you want, but that's good for me. And then we have this guy. All right. Already in standard form. The degree is 4, so I know in the end I should have 4 answers. 4 roots, 4 solutions. So it's good just to check in the end. Okay, factor out a GCF first. I'm left with x cubed plus 27. Oh, look, it's back. T-chart. X equals 0, x cubed plus 27 equals 0. This one's done. It's an answer. And now we have to do this guy. So this particular one is going to have 3 answers now. This. Okay, so I have to soap it out. Remember, x cubed is a perfect cube. Its cubed root is x. The cubed root of 27 is 3, so that goes there. Then we square this one, multiply them together, and then square this one. Same, opposite, always positive. We just factored. T-chart this guy. x is negative 3. Now we have to solve this one. Now, I don't know if you recall me ever telling you this, but I did. This guy right here can never be factored. This one's done. This one can't be factored. When you're doing the sum or the difference of cubes, that trinomial, you have to use the quadratic formula or completing the square. Now that's odd, so I don't want to do completing the square. I'm going to do the quadratic formula. So remember, I'm setting both of these equal to 0. So right now I have this root. I have 2 roots so far. I need 2 more. This one's going to give me 2 more. So quadratic formula, a equals 1, b is negative 3, c is 9. Put it in, x equals negative b plus or minus the square root. B squared minus 4, easy. All over 2a. That's right. Let's sing a song. All right. All right, we plug it in. X equals, remember this is a negative 3, and a negative of a negative 3 is a positive 3, plus or minus the square root of b squared, put the parentheses, minus 4a, c, all over 2a. Figure that out, plus or minus this, what is that number underneath there? All right, so this is negative 27. Reduce this guy. I like to do this over on the side because this is just a big fat mess. So remember that's that. So it's 9 and 3, so it's 3i radical 3. So x equals 3 plus or minus 3i radical 3 all over 2. So there's 2 roots. Here's the third one and the fourth one, or however you want to call it. Done.